Let's talk a little bit about aversive conditioning that is covered in Chapter 3, pages 117 to 120. Do read your book carefully. I want you to learn it there, but I'll just give you a few notes, something to kind of clear up things. So this is a paradigm that's used to actually take a Skinner box and a rat and be able to study classical conditioning, because Skinner boxes were for operant conditioning, but we want to study classical too, so how can we do that? So like you saw in the timing video, we could use a conditioned stimulus of a tone or a light. Those are usually our choices. And then the unconditioned stimulus would be the shock. So we have something that predicts the rat's going to get shocked. Now, it's called a conditioned emotional response. That's CER for short conditioned emotional response, like a learned emotional response. And we assume that the rat is going to become afraid. Now, how do we operationally define fear? Back to Chapter 2, what are we going to do? We need to measure some kind of behavior. We can't ask the rat to introspect and report his fear. So we have to do something with behavior. So the way it's done is he's in his little Skinner box. He's trained to press a lever for food. And so basically he's happily pressing his lever, and then let's say the tone comes on. Now the first time the tone doesn't mean anything to this guy, and so he keeps going, blah, 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 and then all of a sudden he gets shocked. So, oh. Well, you do that about 10 times, right? And now as he's pressing his lever for food and the tone comes on and he's made an association, what do you think he's going to do? Well, he's going to freak out a little bit. He's going to freeze. Now, if the rat is like in his box, what he's not doing right now is pressing his lever. So what we measure, and we can infer fear, but it doesn't really matter. What we measure is a change in his behavior, is that as he makes this association between the tone and the shock, and as that learning becomes stronger, his lever pressing, his frequency of lever pressing is going to decrease. Now we can precisely measure that by using our suppression ratio. We want to give a number like, well, how much is he decreasing it? And we could say, well, he was pressing his lever 20 times a minute, but now he's only doing it 10 times a minute. So he's kind of like half learned. Now if he's got this completely down pat and he has total suppression, how many times a minute is he going to press his lever when that tone comes on? 0. I mean, as soon as it comes on, if he's like, oh crap, he's going to stop pressing it. So if it's perfect learning, his suppression he's going to do it 0 times. So let's look at this equation, suppression ratio. Let's see. What we do is, let me just write it up here. The suppression ratio equals. Okay, I'm going to make sure I don't screw this up. I'm checking your book because it's right here. I tend to get things backwards, so I just want to make sure. Okay. So yes, okay. So what we want to do is, let's say we turn on the tone, and let's say we're just going to play the tone for like 5 seconds. What my ratio is, I count the number of lever presses while that tone is playing, while the CS is on. So let's say this guy presses his lever. I don't want to use the same numbers as the book. Well, let's just say, I don't know, he presses it. I'm going to use the numbers. 50 times. Okay, 50 times. That's a lot in 5 seconds. Maybe the CS is going. All right, so 50 lever presses. Actually, I shouldn't have put that one first. We're going to have the number of presses during the tone, and then we're going to, in fact, forget I even read that. We're going to have the number of presses during the tone, and then on the bottom, we're going to have that same number, the number during the tone, plus the number that he pressed it as his baseline rate. Now, how we get that is we look at, well, how much was he pressing it when the tone wasn't turned on? So again, if our tone is going to be on for like 10 seconds, well, and he presses it a certain number of times during that 10-second tone, his baseline rate is how many times did he press it during 10 seconds when it's quiet? There is no tone. Okay, so let's think about that. So this is the we'll write it this way, during CS, and on the bottom we have that exact same number during CS, and I'm going to write baseline. So I'm going to put same time but before CS. All right, so how many lever presses does it do during the same duration that the CS is, but when it's not turned on? Okay, so now let's ask you. Let's say if this rat is completely new and he has never heard this tone, never been shocked, he doesn't know what's going on. Is his lever pressing going to change at all on the first trial when you turn on that tone? No, it's not. Okay, so now we can start making up numbers. I'll just wing it and see what happens. Let's say, okay, I don't know, he presses his lever 30 times. Let's go with 30. So if his baseline rate, he's just going around and it's like 30 times, all right, let's just do 30 times in 30 seconds, okay? So we'll make our CS go 30 seconds, okay? So when the tone comes on for 30 seconds, we count, or the computer counts, and he presses lever 30 times. Now we put that same number down here, and we say, and what was his baseline rate? Well, if this is a rat who hasn't learned anything, it should be about the same as, he doesn't change, so his baseline was pretty much the same, so we put 30. Now, if we do the math here, 30 over 60, it's a half. We'll put it as a decimal. It's going to be 0.5. So 0.5 is the number you will get for a suppression ratio if your rat has not learned anything. Now, let's say, okay, we'll keep going. He has a few more trials. Let's say he's half learned it, okay? Now, if he's kind of half learned, let's say he slows down. So maybe when that tone comes on now, he just does it 15 times instead of 30. So we put our 15 here. That exact same number goes on the bottom. And then what was our baseline rate? Well, it was 30. That hasn't changed. It's always his baseline. So now we have 15 over 45. Well, 15 over 45 is a third. So in a decimal, we'll put point. So this is, as he's learning an association between the tone and the shock, his suppression ratio number is decreasing, right? Last one, let's say he's completely got it now. He's totally freaked out. He freezes in his box when that tone comes on. He's no lever pressing. So now we have 0 lever presses during the tone. That same number goes on the bottom. And then his baseline has always been 30. That hasn't changed. Baseline rate. Well, 0 divided by anything is 0. So the suppression ratio when he's completely learned is 0. So a couple of things you need to know about suppression ratios. First of all, they go from 0 to 0.5. You theoretically can't have one that's like 0.7. That math wouldn't work. Now, data's sometimes messy and it could happen, but on an exam or a homework, I would only 0 to 0.5. That are your choices. And the lower the number, the more learning. So if I were to say to you, and I will on a homework or something, I have 2 rats. This guy has a suppression ratio of 0.1. This guy has a suppression ratio of 0.4. Who's learned more? 0.1 guy got the lower ratio. That means he's learned more. Closer to 0, the more you've learned. Okay? I think that should do it. Now, there are some questions about suppression ratios in your Chapter 3 Quiz A. So you will have wanted to, read those few pages, hopefully watch this, and watch the video. I have a link there so you can see a rat in one of these experiments. Poor little dude. And then you should get those, okay? Cool.